Hey class, today we're going to talk about adding and subtracting matrices, which is found in section 12-1 of our book. Our objectives are going to be to add and subtract matrices and to solve matrix equations. So sometimes you may want to combine matrices to get new information. You can combine two matrices with equal dimensions by adding or subtracting the corresponding elements, which are elements in the same position in each matrix. There's more information on page 772. So in our first example, we are given two matrices named C and D, and we are asked the following. We are asked to add C and D and then subtract C and D. First of all, on the last slide, there was something that was mentioned of corresponding elements. So I kind of want to mention what corresponding elements are. Corresponding elements are elements that are in the same exact position on different matrices. So in that sense, the matrices have to be of the same dimensions. Remember, you know dimensions by row by column. So there are 2 rows here by 3 columns, and this is also 2 rows by 3 columns. Okay, but as far as corresponding elements, for example, 3 matches with 1 and 4 matches with 3 as far as corresponding elements. So anyway, to add your matrices, we would have 3 plus 1, and then 2 plus 4, and 4 plus 3, negative 1 minus 2, 4 plus 2, and 0 plus 4. You really don't have to show your work if you can do that mentally. So our answer should be 4, 6, 7, negative 3, 6, 4. For addition. Now to subtract those matrices, and I'll do this mentally, we need to go through and take every element from C and subtract it from D. So 3 minus 1 is 2. 2 minus 4 is negative 2. 4 minus 3 is 1. The next row, negative 1 minus a negative 2, that one's worth writing. Negative 1 minus negative 2, remember that's a double negative, so that makes a positive. So that's really 1. 4 minus 2 is 2, and 0 minus 4 is negative 4. So we're going to practice again. We're going to add for try 1. So here we go. This is a, by the way, this is a 3 by 2, right? Because there are 3 rows, 2 columns. So here we go. A plus D would give us negative 12 plus 3 is negative 15. 24 plus 1 is 25. Negative 3 plus 2 is negative 1. 5 plus 4 is 9. Negative 1 plus a negative 1 is negative 2. And 10 plus 5 is 15. Now we've added. Now we need to go through and subtract those matrices. Negative 12 minus a negative 3. Again, I'm going to write that out because it's worth writing. Negative 12 minus a negative 3. Remember, that's a double negative. So negative 12 plus 3 is negative 9. 24 minus 1 is 23. Negative 3 minus 2 is negative 5. 5 minus 4 is 1. Again, this one is also worth writing. Negative 1 minus negative 1. That's a double negative. So negative 1 and positive 1 is 0. And then finally 10 minus 5 is 5. All right, in example 2, it says the first table shows the teams with the 4 best records halfway through their season. The second table shows the full season records for the same 4 teams. Which team had the best record during the second half of the season? So this is actually good information worth knowing. So if we know anything about, actually don't really even need to know anything about sports. You just need to know the fact that it said first half. So if this represents the first half, and this represents the total, then to get to that total, we had to add some other half that is now unknown to get the total. In other words, what they want to know is how do we find that half of the season? Well, to do that, we would subtract whatever this first half season is from the total to find our answer. So what we need to first do is create 2 matrices so that we know what the second half of the season's scores are, and then figure out which team had the best score. So this should be 30, 11, 29, 12, 25, 16, 24, and then 17. This one should be 53, 29, 67, 15, 58, 24, 61, 21. I'm going to go ahead and erase this information at the bottom. But I will write at the top. So again, to find the second half, we will take the total and subtract the first half. Okay. All right, so we have the total. So here we go. 53, 29, 67, 15, 58, 24, and then 61, 21. We're going to subtract that from the first half so that we can find the second half. So it's 30, 11, 29, 12, 25, 16, 24, 17. Okay. All right, so now we're going to subtract. So this would give us 50 minus 30 is 23, 29 minus 11 is 18, 67 minus 29 is 38, 15 minus 12 is 3, 58 minus 25 is 33, 24 minus 16 is 8, 61 minus 24 is 37, and finally 21 minus 17 is 4. So if we look at the last matrix and we try to determine which team had the best record during the second half, that means the most wins with the least amount of losses. It looks like Team 2 had the best record because they had, oops, that's team, sorry, because they had 38 wins and 3 losses. All right, so in try 2, we're essentially doing the same thing, except we are using it without the context of a word problem. So again, to find A, we're going to add B to both sides. So A will equal C plus B, or B plus C. So all we're going to do is add these matrices to be able to find A. So A equals 1, 6, negative 1, 2, 6, 1, negative 1, negative 2, 4. Plus, adding C, that's 2, 0, 0, negative 1, negative 3, 6, 2, 3, negative 1. So our final answer will be 3, 6, negative 1, 1, 3, 7, 1, 1, 3. And that's our answer to A. Finally, in example 3, we are using matrices now to find unknown values within matrices. In this equation, we have two matrices that are set equal to each other. So if anything is set equal to each other, that means that their elements should be the same. So for example, 9 here is the exact same 9 over here, or for example 10 is the same here. So to be able to find our x and our y, all we have to do is set them equal to their corresponding elements in the other one to find their values. So 3x plus 1 equals 16. If I subtract 1 on both sides, I'll get 3x equal to 15. Finally, if I divide by 3, x will equal 5. All right, the second one, we have 2y minus 1 equal to negative 5. If I add 1 to both sides, I get 2y equal to negative 4. If I divide by 2, then y will equal negative 2. All right, and try 3, and this is our last example. It says what values of x and y make the equation true. Now this one isn't necessarily the exact same as the first. This one we need to actually set up the equation to be able to make it true. So let's kind of go through this. So for example, 12 minus 10 equals 2. That makes sense, right? So if we're trying to find x or if we're trying to find y, all we need to do is find where they correspond to. So let's look for x. So I see x is here, so I see 3x minus x is equal to 8. So 3x minus x, that's really 1x, right? So that's 2x equal to 8. If I divide by 2, x will be equal to 4. Okay, now we know what x is. Now to be able to find what y is, I'm going to switch colors. Let's use purple. All right, so to do y, I see a 0. That corresponds to 2y minus 6. And I should, by the way, have put that expression in parentheses, so I'm going to, equals what it corresponds to on the other, which is 4y plus 12. Now, it's very good that I put that in parentheses because if I did not, I would not realize that I need to distribute the negative to both. So here we go. I have negative 2y plus 12 equal to 4y plus 12. At this point, what we notice is that we have variables on both sides, so we need to move the smaller variable. So I'm going to move the smaller variable by adding 2y. I have 12 equal to 6y plus 12. If I subtract 12, 0 will equal 6y, so therefore y must equal 0 because I would divide by 6 on both sides to get 0. And that is it, guys. Remember, if you need any help, any extra tutoring, be sure to come in during our tutoring times. Have a great day.